let me start by asking you, is aging a disease?
That is a really great question. It's a real sort of topic of controversy and debate within the field. I think I just about fall on the half of the camp that says that aging isn't a disease. And that's more for any sort of sociological reasons than biological ones, which is to say that, I don't want to tell everyone over the age of 50 or 60 or, where would we even draw the line that they are quote unquote diseased, just for having lived on this earth for a certain period of time. However, the biological argument is, somewhat compelling. Perhaps it's not a single disease. Perhaps some people like to call it a disease syndrome. I don't really think that sounds a lot better if I'm honest. But the idea is that aging, well, I describe it in my book as the world's biggest humanitarian challenge. And that might sound slightly strange, just as describing age as a disease might. But the reason, the thing that both of these ideas are getting at, aging is the single largest cause of death in the world today, bar none. And that's because aging, the aging process, the biological changes that happen in our bodies as we get older, they're responsible for cancer, they're responsible for heart disease, dementia, stroke, wrinkles, frailty, grey hair, all of these things, some of them deadly, some of them not, but they are all essentially caused by the same biology. And if you add together all the different age-related causes of death, it's something like 70% of deaths globally, not just in rich countries, but all around the world, are caused by the aging process. And so I think that's, why people might want to call it a disease, why I call it a humanitarian challenge, because it really is this enormous sort of hidden pandemic. Most of us just accept it as a natural process, but actually it's such a crucial part of our medical system going forward.
You're not saying, though, are you, that people can live forever, that you can, of the two certainties of life, death and taxes, you can make them just one certainty of taxes because you don't need to be certain about death? That's not what you're saying.
That's very good, yeah. So a lot of journalists do say, so what about immortality? Phrasing that question in the negative is definitely my favourite way to receive it, because this isn't about immortality. If we're talking about any kind of immortality, and the sort of caveated version you could use that word for, is something called biological immortality. Now, what does that mean? It's not as, sci-fi as living forever. What it means is a risk of death and disease that doesn't change with time. So let's have a think about, what it means to be a human being. One of the most fundamental facts about being a person is that your risk of death doubles every 8 years. And this starts out relatively benign. So I'm 37. My risk of death this year is something like 1 in 1,000. And obviously, if you double that in 7 or 8 years' time, I'm going to be looking at 1 in 500. 7 or 8 years' time after that, 1 in 250. These are all, fairly good odds of death as far as I'm concerned. But if I'm lucky enough to make it into my 90s and unlucky enough that medicine doesn't advance in the intervening time, then I'm going to have odds of death in one of those years of roughly 1 in 6. So that's sort of life and death at the roll of a dice. And the reason for this is fundamentally that all of those diseases I just mentioned, the cancer, the heart disease, the stroke, and so on, also get exponentially more likely as we get older. And so all we mean when we think about tackling aging is trying to flatten that curve, essentially, to make people stay fitter and healthier for longer. And they probably will live longer as a side effect, but we're really not gunning for immortality here.
So in ways in which I can understand it as someone that doesn't understand it, what actually is aging from a biological point of view?
It's a great question. It's sort of an active question in the field, but luckily we've coalesced around enough of a definition that we can start to think about treating it. And what I mean by a definition is we've got this list of what are called the hallmarks of aging. In my book, I list 10 of them. It's based on a paper of the same name, The Hallmarks of Aging from 2013. They've got 9. People disagree about exactly what should be on this list, but as I say, there's sort of a broad consensus emerging. And these are changes that happen in all of our bodies as we age, and they seem to accelerate multiple aspects of the aging process. So this can start with the very smallest structures inside our body. So, for example, the DNA, that's the instruction manual at the center of every one of our cells, all the information that's required to, make a human being, to make you. And you can accumulate mistakes in that DNA as you go through your life. And the most famous consequence of that, of course, is cancer, which is effectively a disease where you get too many of these mutations and the cell starts dividing uncontrollably. And that's obviously how that disease arises. Sort of zooming out a bit, I'm not going to go through all 10 just as a relief to the listeners here, but zooming out a little bit, we can have problems not just with what's inside the cells, but we can have the cells themselves become old. There's something called a senescent cell, which is just a biological term for aging, basically. These are cells that are sort of old, clapped out. Maybe they've divided a lot of times. Maybe they've just got a lot of damaged DNA, so it sort of relates to other hallmarks. And that means that stopping dividing, they stop fulfilling their function in the body, and they go on to cause a whole range of age-related problems. And then zooming out even further to perhaps the sort of biggest hallmarks, these can be dysfunctions of whole systems in the body. And one that we've been really reminded of in the last couple of years, unfortunately, is the immune system. So as you get older, your immune system gets increasingly bad at fighting disease, and that's why COVID has been so much more severe for older people. So as a result of all these different hallmarks working together, that's what causes this increase in risk of disease and increase in risk of death.
And that's what aging is. It's an increased risk to diseases. So in that sense, can somebody die of being old?
It's interesting. So this was, I think, actually made disallowed on death certificates in the UK 15, 20 years ago. Yeah. Because dying of old age, it isn't really an actual cause. What caused that person? What caused their heart to stop beating? What caused them to actually die? And almost always there is an identifiable cause. And, it might be something like a heart attack, it might be something like dementia gradually getting so bad that it strangles the cells in the brain that are vital for function, whatever it might be. But I think it's really important that we don't think about dying of old age in the way that I think we used to. Because I think the sort of old-fashioned picture of this is that you get to a certain age, you just go to bed one night and painlessly in your sleep, you don't wake up the next morning. But actually, of course, what really kills you is this accumulation of various different problems. It's often not just one single disease that takes you out, although it might be the thing that strikes the final blow. Most 80-year-olds, the average 80-year-old, has 5 different medical diagnoses and is taking about the same number of pills to fight those various different problems they've got. So, this really is a sort of gradual attrition of your independence, your ability to live your everyday life. And that's what I really think about when I think about people dying of old age. It's that huge sort of burden of suffering that comes along with it.
So what we're aiming for here then in the process of anti-aging or allowing people to live longer is going after those signs of aging and just keeping them higher. So your ability to stave off disease is kept at a high level of someone, say, in their 30s, and how you go about doing that. So let me ask you about the evidence for this. Where is there evidence for, and what does it look like in reverse engineering aging?
So I think the way to think about this is that we want to target those individual, what are called hallmarks of the aging process. So these individual parts, sort of component parts of the biology that change as we get older. And thankfully, for anyone trying to talk about this, both the easiest example is also the one that's furthest advanced in terms of medical developments. So this is something called a senolytic drug. So seno, just from that word senescent, meaning aged, and lytic, just basically meaning it kills these things. It kills the senescent cells that are found in our bodies. And these experiments so far have been mainly done in mice, but there was a 2018 paper which looked at a bunch of mice. It waited until they were pretty old. They were sort of 60 months old. Now, mice obviously live a lot less long than people do, but they were 24 months old, which means they're about 60 years old equivalent in human years. Right. So, you've got to do this little conversion, because obviously anyone who's kept a pet mouse knows they don't quite live as long as we do. But having, given it to these sort of late middle-aged mice, what they found was the mice that had this senolytic drug, they basically, had their biological age turned backwards. They lived a little bit longer, which is obviously a good thing. But they weren't sort of hobbling along in ill health, having had the protracted, period of old age somehow elongated even further. They were free of disease. They had less cancer. They had less heart disease. They had fewer cataracts. They were fitter. So they have little mouse-sized treadmills they use in these experiments, and they were able to run further and faster on those. They had better cognitive function. So you could put one of these mice in a maze. Now, a young mouse in a maze in a new environment is really excited to sort of explore, find out where the food is, whatever that might be. Whereas an older mouse is often a bit more anxious, a bit more sedentary, less willing to explore. But the mice that had this senolytic treatment seemed to have some of that curiosity rejuvenated. And finally, not to trivialize this, but they just looked great. If you look at some of these photos of these mice online, you see the mouse that's had the drug, the mouse that hasn't had the drug. They've got thicker, better fur. They've got less grey fur. They've got plumper skin. I'm not a mouse expert by any means, but even to my wildly untrained eye, they just look fantastic. And what this really shows us is that these senescent cells, they aren't just driving the cancer. They aren't just driving the strokes. They're driving, potentially even the whole aging process. And so hopefully by giving these drugs to humans, we can reverse the aging in them too and delay, much or perhaps even all of aging by attacking one of these hallmarks.
Has that started to happen? Have we started human trials?
There are human trials of these drugs, and I think this is actually a bit of a pattern that's going to follow for a lot of anti-aging treatments. It's currently very hard to get a drug approved for aging because, as we discussed at the beginning, aging isn't really thought of as a disease. Yeah. There's also this problem that the trials just take a really long time. So your risk of death at age 65 is about 1%. That's still pretty good odds. If those odds were to continue, you'd live to be 165 on average. So, you're not likely to die in the next year or 2 or 3, fortunately for 65-year-olds and, anyone who's listening. But what that means is that if you want to do a trial where you give a bunch of 65-year-olds a drug, you're going to have to watch a lot of 65-year-olds for a very long time for just a handful of them to die. And then for, say you've got a treatment group and a control group, in order for there to be a difference between the people getting the drug and the people not getting the drug, you're going to have to wait even longer. So currently these trials are very tricky. So what's going to happen instead is these senolytic drugs are being prescribed for specific diseases where we know that the senescent cells are a problem. But as we start to understand more about how they work, obviously they need to help the people with those diseases. But most importantly, if they're safe, so they don't have any serious side effects, we can start thinking about, dishing these things out more widely. And eventually, as we try them on less and less serious conditions, eventually, we might be thinking about dishing these things out prophylactically to people who are just old enough to have accumulated enough senescent cells that it's worth a sort of preventative clear out.
How long do you think people could live towards then, on average?
It's a fantastic and incredibly difficult question, and it's obviously a very natural question to ask. You've got to think about, what this means from a medical development point of view. And let's take the example of someone who's middle-aged now, maybe they're in their 40s or something. Even, with completely normal modern medicine, if they have a reasonably good diet and lifestyle, they can definitely expect to live into their 80s, maybe into their 90s. And so what does that mean? It means they've got, 4 or 5 decades of medical science ahead of them. Now, imagine these senolytic drugs, they could be available in the next 10, 15 years, something like that. What that then means is they can benefit from these first rounds of anti-aging treatment. And again, if they can sort of, eat well, exercise, do all the standard stuff, maybe they could live another 5 or 10 years longer still. That's another 5 or 10 years longer for scientists to make these developments. In the more advanced, the stem cells, the gene therapies that I talk about in my book, these, they're more advanced than just a pill, but they're not sci-fi. They're certainly not something I'm expecting to be waiting 100 years for them to be turned into medical practice. So it's really, really hard. It depends partly on how much funding we give this kind of research. And obviously, medical research is just hard. It basically depends on luck. So it's really, really difficult to put a hard figure on this, because we're at just this really exciting and critical stage in the science where, almost anything is possible.
So you could, do you think then in our lifetimes, we're about the same age, but in our lifetimes, there are going to be people who on average live to 100 and possibly many more beyond that because of the advances in these kinds of treatments for aging?
I think that's likely, and I think actually it might be, even more than that, because if you look at the trajectory of life expectancy, there's this fantastic graph that looks at what's happened to life expectancy around the world, over the last 200 years or so. And in the top performing country, there's this almost suspiciously straight line performance. It's about a quarter of a year every year, so 3 months a year life expectancy increase in the top performing country. And if you extrapolate that out, and there's, this is a trend that shows no signs of slowing down, then kids who are born in the 2000s, obviously we're a little bit older than that, the two of us, but they can expect to live into their hundreds. And that means that, we're already, we're hot on their heels. You can probably expect to live into our late 80s or 90s. And that means it's not going to take a huge, moving of the needle in medical science terms for us to be getting into our hundreds or, maybe even beyond.
And they're not going to be these 110-year-olds, geriatric, nightmarish, ill health all the time. These are going to be healthy older people because the thing aging that makes them more susceptible to those illnesses will have been suppressed by whatever the drug is that helps them to suppress that aging.
Exactly, and I think that is the most important thing, because nobody wants to live to 120 but spend their last 40 years in a nursing home.
Yeah, absolutely.
And I think the best example of this actually is people who currently make it to the age of 100. So these are people who've got, basically they've won the genetic lottery. They've probably got older parents or, parents who made it to these incredibly advanced ages. And what we find is that these so-called centenarians, they basically defer the aging process by about 20 years compared to people who live in the rest of the general population. The average person who makes it to the age of 100 or beyond is actually living independently until the age of 100. That's not to say they've got no effects of aging, but they're clearly deferring that whole process. And so I think, this shows us biologically it's possible. The question is, can we, bottle whatever it is they've got, turn it into a pill and, give it out to the rest of us?
And then, I was going to ask whether we want to do this, but I'll come on to that in just a moment about where we are in actually making this happen, because there's quite a lot of money going into this research. And indeed, there are some, I think Jeff Bezos has invested a lot of money in starting up companies to look at this. How far advanced is the science and therefore the sort of the environment to actually make this happen within our lifetimes?
It's a really interesting spectrum, and actually I think one of the things that sometimes this billionaire investment can obscure is the fact that we do need to do a lot of basic science. So one of the things I'm really keen to talk about is that the government needs to fund some of this stuff, because there are things that are so at such an early stage that it's too high risk for even massive net worth investors like Jeff Bezos to be particularly interested in. What's fascinating about his investment is he's chosen one of the more long shot aspects of aging biology, but him and a few other investors have cobbled together $3 billion to really give it a good old go. So hopefully, even though that's one of the things that I would have put slightly further down my timeline, maybe huge investments of that sort and the sort of excitement that's generating can move things along a little bit faster. Something like senolytics are very much at the point where common or garden pharmaceutical companies can absolutely be getting involved. So there's a whole spectrum of different sort of levels of advancement of this stuff. But I think what's most important is just that we don't focus on the really cool sort of hot topics and follow Jeff Bezos with his billions, because actually wouldn't it be tragic if Jeff Bezos' treatment works and reverses one part of the aging process, but then we all get killed in some horrible way by an aspect of the aging process we haven't invested so much in. So we're at this really exciting time. We're not like trillions and trillions of dollars away from these breakthroughs. They're very much achievable, but we have to focus on the prize and realize how huge an opportunity this is for medicine and for all of humanity.
Is it though? I mean, there are people who would argue that we're playing God here, and we're messing around in something that is so natural getting old and dying, that one, there's this question of overpopulation perhaps that creeps in, and two, is it something that we really want to go down and do because it's unnatural and playing around with biology? What would you say to that point on, first of all, on overpopulation? Because I know you get very upset about that.
I get very upset about being asked about that, but
yes.
The reason I'm upset about that isn't so much that it's something that doesn't bother me. I almost, at the end, I did a physics PhD before becoming a biologist. Now I was sort of casting around what's the most high impact thing I could do with my career. I almost became a climate scientist because I'm so worried about the problems with the environment. And I think the first thing to say about overpopulation is I really think that's the wrong word to describe this problem, because what we're worried about isn't the people so much, it's the impact that we all have on the environment. It's the climate change, it's the plastic waste, it's the toxic pollution of various kinds, the land use from farming and that kind of thing. So really, it's not about the people, it's about how much we use. And actually, really, if you drill down into the statistics on this, it's actually about how much the richest, say 10% of us use. So for example, roughly the richest tenth of the world population use about half, or emit about half of the carbon dioxide that's emitted globally. And actually the bottom 10%, they emit so little carbon dioxide that we could basically eradicate them from the earth. I'm not suggesting this is a policy, but we could do that and have almost no impact on our future climate trajectory, for example. So clearly the issue is resource use, and we need to find a way, if we're going to bring all those poorer people in poorer countries up to our quote unquote Western standard of living, we're going to have to find a way to do so with a much smaller footprint on the planet. I think to specifically address the question from an aging point of view, it's actually remarkable how little impact, even a complete cure for aging, so this sort of idea, if we could make a risk of death that didn't vary with time, how little impact that would have on population globally. So I tried to do a bit of modelling from this. I'm by no means a demographic expert, but I just took the UN's population projections and effectively cancelled deaths due to ageing, because you can quite easily do the sums on that. And that means we go from 9.8 billion people in 2050, which is the UN's current projection. Obviously, we just passed 8 billion in the last few months. We go up without ageing to 11.3 billion. Now, is that a lot? On the one hand, it's more than 1 billion people, it's not nothing. But on the other hand, it's only an increase of about 16%. Would I work, 16% harder to reduce my carbon footprint, to do various things to contribute toward improving the environment, if that meant far less cancer, far less dementia, far less heart disease, all of these huge, huge killers, drivers of suffering around the world? Of course I would. And that's in sort of, if you're a population pessimist, that's the worst case scenario. That assumes we basically cure aging today, which, by the way, as I was sort of just trying to illustrate with that idea of how soon this stuff's going to be, it's not going to happen that quickly, and we're certainly not going to be distributing these drugs globally in that sort of timescale. So actually, we're going to have a much more gradual increase in the size of the problem. So I really think, although this is a really obvious first question to ask, actually it's a much smaller issue than it seems initially.
And as you say here, it challenges the bias towards the status quo of aging and dying, of being old, as sort of inevitable. You say if we lived in a society where there was no aging, and suddenly 2/3 of people started degenerating over decades, started losing their strength, losing their mental faculties, and succumbing to these awful diseases, it would be unthinkable. And of course, we'd set to work trying to cure it.
Absolutely, yeah. And I think there's just this strange thing that we've all grown up, our species, our pets, our farm animals, everything we see around us seems to age. And so therefore, we just assume it's this natural thing, it's part of being alive, and we sort of explain it away as a good thing. But actually, we're very, very willing as a society to tackle the individual aspects of the aging process. We're very happy to talk about cancer research. You never get cancer researchers being asked about overpopulation. We invest in medicine for people with heart attacks. We invest in walking sticks and aids for people around their house to assist them in living as older people. So why wouldn't we go after the biology that's causing all of these things and more? I just see that as an extension of modern medicine. And I think it requires a bit of a sort of mind shift compared to how we normally think about aging. But I think once you've made that shift, suddenly, it all sort of clicks together and the whole world just makes a lot more sense.
And actually changes the notion of medicine, what medicine is there to do, and rather than necessarily to treat an illness that someone has, which of course it should be there for, but ultimately to be preventative from getting that illness in the first place. And if halting aspects of aging helps in doing that, well, why the hell wouldn't you?
Definitely. There's a great quote, I think, from a former health minister who said, I'm not in charge of the National Health Service. I'm in charge of the National Sickness Service. Because why do you go to your GP? Why do you go to hospital? It's because you've got a lump or a pain or, something's wrong with you. And then medicine is going in with older people, essentially at the last possible minute, they've got cancer, but at the same time as you're trying to treat that cancer, their heart might be failing, they've got a bit of, cognitive decline, their brain's not working quite as well as it did when they were young. You're fighting this disease in a body that's, failing on a whole load of different fronts. So it's just basically a losing battle. And that's ultimately what medicine is if you intervene at this very, very late stage. But if we embrace prevention, and this is anti-aging medicine that we should be trying to develop, but it's also the basic stuff like diet and exercise and helping people, get more active in their everyday lives, all kinds of different approaches. We can start to make this medicine more preventative. It's going to save a lot of lives, it's going to save a lot of suffering, and it's also going to save a lot of money. So to me, it's just a no-brainer.
Finally, do you think that this is sort of unstoppable now? That this rise in life expectancy alongside what could be the preventative cures for aging, to the point where someone born tomorrow will be able to expect to live to 100 years and beyond?
I think it's really important that we don't consider it unstoppable. I think it's very likely that these kinds of developments are going to happen in our lifetime. But unfortunately, the levels of investment in this research are just absolutely minuscule. And we really need to think about, concentrating on this. As I said earlier, getting our eyes on the prize, realizing what a huge, huge benefit this could be for the whole of society. For everybody all around the world, all of us are aging, and all of us are going to be facing down these diseases and various consequences of the aging process at some point. But the problem is, firstly, these are very, very small amounts of money. So to take the example of cancer research, we spend less than £3 per person per year in the UK on public funded cancer research, which is just mind-boggling for a disease that kills a third of us. Now, I tried to find out a similar number for aging research. The first problem is the government doesn't even have any kind of record of how much we spend on aging research, because it's not even considered a sort of separate category. It's not something that's in the taxonomy of, government research spending. But when you do try and cobble together the numbers from various sources, it's probably something like 40p per person per year, so 40 pence, into something that's got, in the UK, around a 90% chance of being what ends your life. And before your life ends, of course, it's going to be making you frail, it's going to be making you suffer in a whole load of different ways. This is just mind-blowing, to me, and there's no rational possible explanation for why we spend so little on this research. I'm really hopeful that even with this level of research, we're going to see some breakthroughs in the next 5 or 10 years. But, what would really, really transform this is if we decided to take aging seriously. We acknowledge the scale of this problem, but also the scale of the opportunity here, and really decided as a society to do something about it.
Terrific to talk to you. Thank you so much.
Thank you very much.
Absolutely fascinating. And thank you for being there for us.
Thank you very much. It's been a pleasure.
Thank you, Andrew.